Yeah, this is on mixing heptane and octane. Okay? Sorry students. On mixing heptane and octane form an ideal solution. They form an ideal solution, that is the solution which obeys Raoult's law. Means the solution whose total vapor pressure is equal to the sum of the partial vapor pressures. That is an ideal solution. At 373 Kelvin, the vapor pressures of the two liquid components are 105 kilopascals and 45 kilopascals respectively. Vapor pressure of the solution obtained by mixing 25 grams of heptane and 35 grams of octane would be. Now what your Raoult's law suggests, that for an ideal solution, or you can say in an ideal solution, or a solution is said to be ideal when the total pressure of solution, here it's of course vapor pressure, right, of solution is equal to the sum of partial pressures of the two components, right? So what is the total pressure given over here? You have to find out the total pressure, that is P. What is partial pressure of A? The mole fraction of A multiplied by the pressure of A, that is the pure, plus the mole fraction of B multiplied by the pure pressure or the pressure of the pure B, pure solvent, right? Now what is A here? The mole fraction of heptane, I can say. So what is the mole fraction of heptane? The number of moles of heptane divided by the total number of moles, right? So what is the number of moles of heptane? The weight in grams of heptane dissolved. How much weight of heptane is dissolved? 25 grams, right? So it is 25 divided by the molecular mass of heptane, that is 100, divided by 25 upon 100, plus the number of moles of octane. How much of octane was added? 35 divided by 114, right? So if you solve this, you'll get mole fraction of heptane, right? So that is approximately 0.25 divided by 0.25 plus what will be the, should be 0.3, 0.3, right, approximately 35 divided by 114, right? So I was right, my approximation 0.30. Now your 0.25 divided by, it would be 0.55, right? Let's take it up, round it off. What you'll get? 0.45, right? If I am rounding it off as 50 and as 250, right? So I will get 0.45. Likewise, the mole fraction of octane will be equal to what? 35 divided by 114, that is divided by 25 by 100 plus 35 by 100. So here I'll get as 0.55. See, this would be 0.35 divided by 0.55. So if it's 35, round it off, you'll get 0.55. Now you want to calculate the total pressure. Total pressure is equal to 0.45 mole fraction of heptane into What is the pressure of heptane? Pure heptane 105 kilopascals. So this should be 0.45 into 105 kilopascals plus 0.55 into 45 kilopascals. Now this will give you your total pressure. So this you need to do, that is 0.45 multiplied by 105, that is 47.25 plus of 0.55 multiplied by 45, and that is 24.75, and that comes out to be 72 kilopascals. So the total pressure of the ideal solution obtained by mixing heptane and octane, whose pressures, that is a pure solvent's pressures, are 105 kilopascals and 45 kilopascals, is how much? 72 kilopascals. So what is the right answer? Option A.